All right, let's take a look at this Newton's law of gravity calculator together. There's a lot here, so I just want to highlight why I've included it and how you might want to play around with it. The first thing I want to highlight here is that our equation that we're accustomed to is right here. This is Newton's law of gravity. So the force of gravity equals G times m1 times m2 divided by r squared. And you saw in an earlier video when I put that into Google, it's a big equation when you're like typing it into your calculator. And it's especially confusing here because they have all these units, added on here. But you can kind of just ignore those for now, right? All these units. So we're just looking at, G, 6.67 times 10 to the negative 11 times mass 1 times mass 2 divided by r squared. And the end result, the answer that this equation produces is in units of newtons here. And you can see here's that answer. The other stuff we can kind of ignore. This is for acceleration. We're not going to be talking about that. Now, why I think this is kind of a handy calculator is because it has pre-programmed into it a bunch of different masses. So if you were kind of curious, like, okay, what is in fact, the default here is the mass, the force of gravity on a 1 kilogram apple, or what is that? Less than a kilogram. It's a 0.1 kilogram. So you might remember, when I did this calculation, I used a 1 kilogram apple, which I guess would be a really big apple. A small apple would be 0.1 kilograms. That's 1 times 10 to the negative 1. And between that's mass 1, and mass 2 is the Earth. And you can see they find a force of gravity of 1 Newton using a distance like we did of the radius of the Earth. But you might be curious, like, okay, well, I want to know what's the force of gravity between a person, so 72 kilograms, and another person when those two people are at a social spacing of 2 meters. Oh, and my things moved around here. But you can see by comparison, it is an incredibly small force of gravity, right? This is like, 100 millionth of a Newton, which is why, of course, gravity isn't something we typically experience in our day-to-day life, except between us and the Earth, right? Okay, I'm gonna get this out of the way so that we don't get confused there. So I think it's kind of interesting to see, like, what are some other examples of gravity? So like between a large mountain and a person. So if you were standing on a large mountain, and you'd have to find like an appropriate distance, right? Which might be like, how far away would the center of the mountain be? It might be something like a few kilometers, right? And so here it actually is like it's not noticeable amount of gravity, but it is measurable, right? This is like 0.6 newtons. So the amount of gravity of a mountain pulling on a person is actually something that could relatively easily be detected. Now this calculator also goes to really big things, like what's the force of gravity, let's just say between Jupiter and the Earth, maybe. Let's find Earth on the closest approach to Jupiter. So that's really a huge number. So closest approach means like the closest distance that the Earth and Jupiter ever experience. And you can see this is a huge number, right? Like billions and billions of newtons of gravity and Earth tugging on each other. In fact, of Jupiter and Earth. And so you can see that actually Jupiter has a pretty significant gravitational impact on our solar system because it's such a huge planet. And of course, here's the sun and the Earth, which I could use the distance to the sun, right? So this is the force of gravity that the sun has acting on it. So you can kind of get a sense of scale. That's why I wanted you to see this. Now, you could also, in principle, use this when you're encountering problems in our course. If you're given a couple of masses, like, so say a problem gives you a mass, you can actually type those right into this box, and it will give you the answer right here in newtons. There are lots of gravity calculators if you're having trouble with Newton's law, like the actual equation. I showed you how you can just plug it right into Google with parentheses and get your answer. But I just wanted to show you that there are other calculators that you could use. This is a personal favorite just because you can click on all these existing masses and stuff. But all right, that's what this is all about. Hope you find it useful.